Okay, I am new to this, so please bear with me. I think I've got it. All right, so this first week, what we're going to do, or this first week, we're going to talk about um, dimensional kinematics. And kinematics, oh, there's a definition here in the PowerPoint, so it'll explain. But the motion of automobiles, Hot Wheels, rockets, anything like that, something with wheels, well, even a ball. But these are used to illustrate physics of position, velocity, and acceleration, and kinematic graphing. So within this first week, you're gonna, if you don't do graphing within the first week, you'll do it next week. And I don't think I go that far with this one. Okay, so kinematics. This is the science of describing the motion of objects. We're going to use words, we're going to use pictures, we're going to use numbers, graphs, and equations. So kinematics covers a whole big spectrum of physics. And the first thing we're going to talk about is motion. Happens all around us. One-dimensional motion is the simplest form of motion. That just means moving it just in one direction, back and forth, right and left, up and down, just in one direction, not up and over, not just one direction. Okay, so motion takes place over time. So just think about when you're walking to and from the store. You're only going in one direction. You're going forwards, or, I don't know if you walk backwards or not, but you're going forwards, and it takes you X amount of hours or minutes to get to where you're going. And this all depends on your frame of reference. Now, the frame of reference is called the coordinate system, and it's for specifying a precise location of objects in space. So that just means, like, when you're moving, if I am starting here at point 0, this is my 0, 0. If you think about the coordinate system on a graph, this is my 0, 0. All right. The choice of the reference point is arbitrary. I don't have to be in this chair. I can be outside the building. I can be anywhere. But once you say, okay, this is my starting point, then this has to be the same point throughout the whole problem that you're talking about. Distance and displacement. Now, this was something that I had a couple questions about yesterday. Hi, Shay, how are you? Okay, so now we're going to talk about distance and displacement. Good. So, distance. Whoops. Hi, Jamie. Distance and displacement are two quantities, and they may seem the same, but they are definitely different. All right, they have different meanings and they have different definitions. Distance is a scalar, and scalar means that it's just a number. There is no direction at all given to a scalar quantity, and it refers to how much ground an object has covered. Displacement is a little bit different. This is a vector, and it refers to how far out of place an object is. All right? It is the object's change in position. So this one does have, this one does have a direction associated with it. All right? It can be positive or it can be negative. So we are going to talk about this. And this is just a quick little problem. So you have your physics teacher, remember, you decide where you're going to start this, right? So your physics teacher walks 4 meters west, or I'm sorry, 4 meters east So if you have a piece of paper or pencil, you can kind of draw this. And if not, just think about it. So we're going east 4 meters, then we're going south 2 meters, then we're going west 4 meters, then we're going north two more meters, okay? So kind of like you're walking in a square. All right, so here's the picture. Raise your hand or, give me a smiley face or type in the chat box and let me know, does that make sense to you? I don't think you can see my pointer. Okay, good. Nice, nice. So if I were to ask you a question, my first question would be, and you can't see it here because I didn't realize it wasn't going to show up, but what's the displacement? Type it in the chat box. What's the displacement of your teacher here? Give you a minute to think about it. Remember, displacement is the change from your starting position. So you can't see anything here. Naomi says none. Jamie has a big question mark, which is perfectly fine. And, oops, Shay is typing none. Shay says none. All right, so if I start here, and I'm sure you can't see which is kind of upsetting. So I'm going to say that my starting point is in the upper left corner. Okay, are we all starting at the same place? Do you see that? Smiley face or something. I don't know if you can do smiley faces here. Okay, so I'm in the upper left corner. My first movement is going to be to the right, 4 meters to the end of that arrow. Then my second movement is going to be down 2 meters. Okay, so I'm going to the right first, then I'm going down. Now I'm going to the left 4 meters, and then I'm going up 2 meters. So I'm starting and stopping at the same spot. Think about going around that track, that Indy 500 track. Car starts at one spot, ends up at the same spot. So the displacement in this particular case is none. Yay. All right, now let's think about the distance. How far did this physics teacher walk? Oh, sorry, everybody. I didn't see Naomi. I didn't see your comment. Yes, 12 meters. 4 plus 2 plus 4 plus 2. 12 meters. So the displacement was 0, but the distance was 12. Good. And you can't see that, but they're coming in. All right. So we're going to look at this diagram below, and this one is actually in your one of your problems in your practice. So we're going to use this diagram and we're going to determine the distance traveled by the skier and the resulting displacement. So you guys have already done this. And if you haven't, Naomi, I don't remember seeing yours, but if you did, that's great. But you're going to start at A. So this is one of the things that I guess I didn't explain very well. You're going to start at A, you're going to go to B, then back to C, then forward to D. Okay? So think about it for a minute. I know that Shay and Jamie, you guys have already done this. So what is the distance now that this skier traveled? Okay, I got one answer. Yay. Do you guys agree, disagree? It's really important that you guys participate here because I don't care if it's the wrong answer at all. It's just really important. A to B to C to D. Right, yes. I'm going to give you just a couple more minutes and then we'll go over the distance that this skier traveled. And just FYI, any of you guys ever gone cross-country skiing? It's hard. All right. So 420. So they went from A to B, so that's 180. Back to C, that's another 140, and then over to D, and that's another, and it's 420 meters. That's how far. Make sure that you put in your units. Meters is just an M. So what about the displacement? Again, going from A to B, then to C, then to D. How far is his displacement? All right, displacement is 140 meters. And in this particular case, what would you would say to the right? All right, just because our starting point is over there on the left side of the page. Good, that is excellent. All right, so, and again, this is another one, and don't look at the answers. You guys probably already have it. So we have this football coach. I don't remember what it was in the practice that you did, but he starts out here at A, right? And remember that displacement and distance happen over time. So what's happening here is that this Seymour guy is moving 6 minutes. Oh, I'm sorry, takes him 3 minutes to go over here. Okay, 3 minutes to go to B, then 3 more minutes because a total of 6 minutes and he's back at C, and then it takes him 4 minutes to get over here to D. That's what the minutes stand for. And does that make sense to everybody? Starts out here 0 minutes, 3 minutes to get to B, 3 more minutes to get to C, and that's 6, and then 4 minutes to get to D, and that's how they get the 10 minutes. All right. So his distance that he traveled, is this what you guys got? I think it is. Jamie, Shay? Yeah, good. The distance that he traveled is 95 yards. And remember that distance is a vector. It doesn't have any kind of right, left, positive or negative associated with it. No direction. Displacement, however, does. And if we were thinking about this, his displacement would be 55 yards to the left. All right? All right, let's go. Get this done. So displacement, this is an algebraic type of formula. So what this stands for, displacement is change in position. And this triangle, do you guys know what the triangle stands for in algebra? Okay, it means delta, and delta means change. All right, so anytime you see that delta in front of a variable or a letter, that means the change in this particular case, x, okay? So change in x. So this is equal to x final, that's what the F stands for, minus x initial. So where they end up minus where you start, all right? And that's how you get your right, left, up, down, okay? All right. Speed and velocity. Let's do this one real quick. I think this is the last part, I hope, because my computer's about to die. All right, so speed is a scalar quantity, and it refers to just how fast you're going. All right, it doesn't have any direction to it. Velocity is the vector quantity, and this refers to the rate at which an object changes its position. So when you think about in your car, all right, your speed, that's what your speedometer is actually telling you, how fast you're going. All right, velocity, positive velocity means you're moving forward, negative velocity means you're moving backwards. All right, so velocity is speed with direction. Oops, that's just a picture. That's just an old lady that has been driving. So we're going to do one problem, average speed and velocity. So the average speed, this is just your average, is the total distance that you've traveled divided by the time interval. So if you've traveled for 60 miles and you went that 60 miles in 1 hour, obviously you're traveling 60 miles per hour. Now, average velocity is the total displacement traveled divided by the time interval. So this would be something to maybe write down in your notes if you haven't already. But the speed is distance divided by time. Velocity is displacement divided by time. And if you remember, distance is a scalar quantity and displacement is vector. Oops, there you go. Yay. All right, so these are your formulas for average speed and average velocity. And I know there's only a couple guys here, or ladies, sorry, but what I want everyone to know is that I really want you to keep a notebook, next to you when you're doing your lessons and your practices, because anything that you write in your notes or in your as far as formulas are concerned or definitions, you can definitely use those on your practices. And formulas you can definitely use whenever you take it, whenever you're taking that unit test. Okay, so while on vacation, Lisa Carr traveled a total of 440 miles. Her trip took 8 hours. Hopefully, you guys, if you don't have a calculator, that's okay. What was her average speed? See if you can do this one. And I'll see if I can do it too. Okay, I'm going to wait till Naomi finishes typing. All right, so remember, we are dividing miles by hours. So her average speed was 440 miles divided by 8 hours, 55 miles per hour. So close, Shay. Don't forget to look at your units. Units will help you with a lot of things that you maybe think that you're not getting. If you can cancel out units or write down your units, you'll be doing great. Okay, so if a car travels from city A to city B, and that distance is 100 kilometers, if in the first half of the distance is driven at 50 kilometers per hour, the second half is 100, what is the average velocity? Now this one's kind of a challenging problem, and I just put it in there just so that you can see, and we're going to look at the answer right now. Think about the problem, kind of write down, if you have some paper and pencil, write down that information so that you can see where it's all going to be used. Okay, ready? Let's go. Okay, so from A to B, it's 100 kilometers per hour. The first half, they drove 50 kilometers per hour. So in the first half, right, 50 kilometers, that's half of it. 50 times 50 probably took him an hour. The second half, there's another 50, and he's driving at 100 kilometers per hour. So that's probably a half an hour. Oh, look at that. Kind of did that in my head. Yes. All right. So, almost done. The average velocity is displacement divided by time. So the total time that this person was driving is an hour and a half. The total displacement is 100 kilometers. So he was driving, or she was driving, 67 kilometers per hour. All right. So I'm going to leave this up here just for a minute so you guys can look at it. It's, as I said, it's a little bit challenging, the problem is, but at the same time, it's something that you guys can, I think you can understand. All right, give me a thumbs up or something, and let me know when you're ready to move on. I don't think there's much left. All right, thanks, Jamie, Naomi, Shay, thanks, guys. So constant velocity is velocity where you're never changing. And instantaneous velocity is velocity at a specific point. Just my little, I was really surprised that this was working in PowerPoint for me, so. Okay, so, oh my goodness. Motion versus position time graphs. This is actually next week. So I'm going to stop here. I get carried away. And let me know if you guys have any questions. Anybody? All right. Good. Good. This will be for next week. And please, if you have any questions, send me a message. I will have my phone on Monday. Catch me in the labs. All right, guys, that's it for today. Thank you so much for coming. All right, bye. Oh. Mm-hmm.